में अच्छा हो जाए। Hello, good morning, everyone. Very good morning, and let's get started with the today's class. So, in today's class, I'm going to discuss some questions from SHM. One question I will be taking up from gravitation, rest from SHM and wave. Okay. In wave, we will be revising a bit of how to write equations and what the important topics are. So that we will be taking care of. Done. So let's get started. And in between, if you get any doubt, you can let me know. Okay. Chalo. Okay. So let's do the very first question. And very first question is here on your screen. Which chapter? So wave या SHM you're talking about? Wave. कोई चाप नहीं है. That chapter is actually very easy. तो मैं उसका I will let you go through the chapter. I will just tell you about the important points that you need to remember. Done. And after that, we will be doing questions. Okay. So I will be taking care of those things that you said, now you have not gone through it. So accordingly, I will explain things. No worries. Nitin, good morning. Chalo. Is question में, even if you are not coming to the answer, I just want you to draw the diagram, understand the thing, what is happening. Done. Because you know what happens in G advanced approach is very much important. If you're able to think about questions, that will also help in some other question. Like if you are not able to solve this question, thought that you are putting here may help you solve some other questions, right? So putting thought is also very much important in G advanced questions. तो आप इस क्वेश्चन को ध्यान से करो और करोगे तो हो जाएगा. क्वेश्चन इज नॉट डिफिकल्ट. अगेन चलो लेट मी नो. गुड मॉर्निंग वंस. वेरी गुड मॉर्निंग. गुड मॉर्निंग जय. Okay, so second line है, if PR is the pressure at R less than R. Actually question is something like कि suppose कर लो तुम्हारे पास एक hollow sphere है, done. So if it is a hollow sphere, what is inside? Air, done. Now what is happening? Air is getting replaced by a fluid. So suppose कर लो कि inside this hollow sphere I am pouring water inside, so it has water. Now water inside is in equilibrium. It is said that a spherical body of radius r consists of a fluid of constant density and is in equilibrium under its own gravity. Under its own gravity, it is in what? Equilibrium. ठीक है? तो what will happen here? Just locate the center of this sphere. So if this is the center of a sphere, and if this liquid is in equilibrium, it means whatever portion of liquid we are picking up, that on that portion of liquid, net force acting is what? Zero. Now, what things can apply force on it? कौन apply कर सकता है? So you just remember things carefully. जैसे क्या है ना, gravitation formula and electrostat formula you can relate so much. तो आपने electrostat में जरूर पढ़ा होगा कि if this is a sphere, solid sphere suppose, and there are charge, जैसे hollow sphere में आपने पढ़ा होगा कि if hollow sphere has a charge q on its surface, electric field inside is zero. Done. So इस चार्ज की वजह से इलेक्ट्रिक फील्ड सिर्फ आउटसाइड या सरफेस पे होगा. that you have studied, right? And in solid charged solid sphere जो कि नॉन कंडक्टिंग है, उस केस में अगर charge is distributed uniformly inside, and if you are picking up any point here, so on this point electric field will be only because of which charges here, like whatever charges, जैसे इसके यहाँ पे हमने जो पढ़ा है ना, इलेक्ट्रिक फील्ड का फॉर्मूला क्या लिखते हैं हम लोग? E इक्वल टू वी राइट रो r बाई 3 एप्सिलॉन नॉट. वी राइट ना, यहाँ पे हम लोग इलेक्ट्रिक फील्ड अंदर क्या लेते हैं? जीरो, और बाहर क्या लेते हैं? k q बाय r स्क्वायर समथिंग. एंड व्हाट फॉर अ नॉन कंडक्टिंग सॉलिड स्फीयर, we write it rho r by 3 epsilon naught, where rho is charge density. Similarly, अगर यहाँ पे मैं consider करूँ, if I am taking a strip of water, suppose I am taking this strip of water at radius r, and suppose कर लो this water has certain amount of thickness, so this strip I have taken, its thickness I have taken as dr, suppose it is taken as radius r. So what will happen to this strip? If I am writing this strip somewhere outside like this, and this strip is in equilibrium, so net force acting on it should be what? Zero. Force on it will act because of what? Because of mass, gravitational force will act, and because of pressure. Done. So gravitational force, if you are going to write, what will be the gravitational force value on this strip? So we will calculate कि यहाँ पे g का value क्या है, small g का value क्या है. So what will be the value of a small g here? We will be writing a formula. ये वाला rho r by 3 epsilon naught. Again, epsilon naught we use for charge वाला thing. What we will be using here, जैसे we can use this formula for writing g here, and we will replace epsilon naught. जैसे आप दो चार्ज के बीच के फोर्स को क्या लिखते हो? k q1 q2 by r square. दो मास के बीच के फोर्स को क्या लिखते हो? g m1 m2 by r square. There is a good analogy between electrostatic force and gravitational force, and hence between formulas getting used in electrostat and in gravitation, right? So यहाँ पे q charge is analogous with mass, distance same, so k will be analogous to g. It means 1/4 pi epsilon naught can be replaced by g in case of gravitation, right? So यहाँ पे in the formula we are getting epsilon naught. So epsilon naught can be replaced by what? 1/4 pi g. Done. So this formula we can use here. तो g का value यहाँ पे क्या लिखेंगे? Electric field का value था rho r by 3 epsilon naught. Gravitational field at distance r will be how much? That will be equal to density of liquid into distance at which we are calculating, that is r. 3 into epsilon naught can be replaced by 1/4 पाई जी, ठीक है, 1/4πg। तो आई टुक अप दिस क्वेश्चन जस्ट टू एक्सप्लेन यू कि हाउ वी कैन इंटरचेंजेबली यूज फॉर्मूला ऑफ इलेक्ट्रोस्टैट इन ग्रेविटेशन, ठीक है। So we can openly do it. So this will be the value of G here. Now, if value of G at this point is this one, then what will be the gravitational force acting here? Definitely this force will act downward towards the center. And what will be its value? Mass of this strip. Then what will be the value? It will be equal to gravitational force I am going to write. So this will be equal to mass of a strip. Suppose कर लो कि इसका एरिया मैंने ले लिया dA और A suppose कर लो, and its thickness is dr. So its volume will be, sorry, what I am going to write? I am going to write force ना, हाँ, force मुझे क्या लिखना होगा? M into G. G already I have written. So mass मैं पहले लिखने की कोशिश कर रही हूँ. इसका एरिया मैंने A लिया, thickness is dr. Its volume will become A dr. Its density is rho, so mass will become A rho dr. Into क्या लिखोगे? G. So G का वैल्यू क्या होगा? Rho r by rho r 1/4πg था ना, so 4πg ऊपर चला जाएगा by 3. So this is the gravitational force acting on this strip. Then this one we have written. Now let's deal with the pressure. So if it is in equilibrium, net pressure must act upward. राइट, सो अगर मैं प्रेशर, नेट प्रेशर इस पे एक्ट करता हुआ डाउनवर्ड डायरेक्शन में प्रेशर को मैं क्या लिखूंगी? सपोज कर लो मैंने लिख दिया P एंड यहाँ पे प्रेशर लिख दिया P प्लस डेल्टा P. सो मैं यहाँ पे प्रेशर को क्या करने वाली हूँ? दिस डायरेक्शन का प्रेशर, जैसे मैंने प्रेशर कुछ ऐसा लिखा कि इस डायरेक्शन के प्रेशर को मैंने क्या लिख लिया, that I have written as P, and इस डायरेक्शन के प्रेशर को मैंने क्या लिख लिया है? P plus dP. तो obviously to equate like net pressure force would act in the upward direction, इसलिए मैं P minus करूंगी नेट प्रेशर फोर्स में लिख रही हूँ, ठीक है। तो प्रेशर फोर्स में क्या लिखूंगी? अपवर्ड डायरेक्शन में लिखूंगी, तो मैं क्या लिखने वाली हूँ? P minus dP into area. So what it will be? Minus dP area. So this is the net pressure force in the upward direction. This is net gravitational force in the downward direction. Equate these two. अब आप इन दोनों को equate कर लो, and then you will be getting formula for pressure at any distance r. तो आप उसकी values को put करके you can check with this, ठीक है। So how you will be doing that? You will be writing minus dPA will be equal to how much? It will be equal to A rho dr. A रो का स्क्वायर में करती हूँ क्योंकि दो रो है, ध्यान से देखो, दो रो है, रो का स्क्वायर किया मैंने, 4πg इंटू आर है, तो यहाँ पे जो कांस्टेंट है उसको पहले लिखते हैं 4πg r dr, ठीक है। दिस इज डन, r dr डिवाइडेड बाय क्या है हमारा 3. नाउ डन, दिस इज। अब हमें क्या करना है? देखो ए तो कैंसिल हो जाएगा, दैट इज ओवर। लिमिट कैसे लेना है? लिमिट हियर इज वेरी इंपॉर्टेंट। जैसे आप एक चीज देख लो, अगर हमारे पास लिक्विड है, सपोज दिस इज माय लिक्विड, सो दिस लिक्विड विल एक्सर्ट हाईएस्ट प्रेशर वेयर एट मोर एंड मोर डेप्थ, ठीक है। डेप्थ वी विल मेजर फ्रॉम द टॉप, सो एज वी विल गो डाउन व्हाट विल हैपन? प्रेशर विल इंक्रीज ओवर। सो यहाँ पे भी इफ जैसे मैं इस डायग्राम को इधर ही बनाती हूँ, यहाँ पे लिक्विड है ऐसे, सो एज वी विल गो फ्रॉम r इक्वल टू r to r equal to 0, what will happen? As we will go from top to down, pressure will what? Increase, right? So we can assume that pressure at r will be equal to what? Pressure at r can be taken as 0, so इसको मैं 0 मान सकती हूँ, and pressure at any value small r can be taken as p. So minus dp का जो इंटीग्रेशन होगा उसको मैं क्या लिख सकती हूँ? सिंपली p माइनस p समथिंग लिख सकते हैं, है ना। अब यहाँ पे आप लिमिट कैसे लोगे? मैंने r को पहले रखा है, जीरो प्रेशर, 0 to p आई एम गोइंग, सो यहाँ पे मैं लिखूंगी r टू स्मॉल. नाउ डिफरेंशिएट अकॉर्डिंगली, सॉरी इंटीग्रेट इट, यू विल बी गेटिंग द आंसर. सो यहाँ पे दो चीजें इंपॉर्टेंट था. वन थिंग वाज हाउ यू विल बी टेकिंग small g value at any position vector R. So that we can easily take from the formula. Done. And second thing was taking up limit. How we will take up the limit? So limit जैसे देखो हम लोग जब ऐसे लिखते हैं ना dv equal to something आता है at square dt, तो हम क्या करते हैं यहाँ पे कुछ लिमिट नहीं रखते, डायरेक्ट इसको b लिख देते हैं. ये हम कब करते हैं? when at t equal to 0 हमें v भी क्या दिया होता है? v भी 0 दिया होता है. And at any time t velocity v होता है, तब हम लिखते हैं v minus 0. So it's important कि at what point this pressure is 0. So high chance is at r position vector it will be. So यहाँ पे मैंने इसलिए r ली. ठीक है. So picking up limit is very important. Done है सबको? Clear है? Done. चलो इस क्वेश्चन को करो. क्वेश्चन इज इजी यार, इट्स नॉट डिफिकल्ट. फॉर्मूला अगेन याद रखना है, रेंज का फॉर्मूला क्या था, और थोड़ी थोड़ी चीजों को कॉन्सेप्चुअली धीरे धीरे मूव करना है, नथिंग एल्स. सो क्वेश्चन इज इजी बट यस टेक टाइम and do it. I'm giving you some 4 minutes. I really want you people to solve this question. Do this now. क्वेश्चन को ना प्यार से देखना चाहिए, like give it some love, some respect. It will come to your hand. तो सही से करो. चलो डन है. So you need more time. Okay, let's read the question. A small block is connected to one end of a massless spring of unstressed length 4.9 meter. Yani ki when it is in unstressed position, this length is how much? 4.9 meter. That is given in the question, right? The other end of a spring is fixed. Other end, यहाँ पे एक end fixed है, and other end is connected to a small block. Done here of some mass n, suppose. Now the system lie on a horizontal frictionless surface. Again, question is being made easier by assuming or by telling that friction here is what? 0. Over. Now what is happening? The block is stretched by 0.2 meter and released from rest at t equal to 0. At t equal to 0, what is happening? We are stretching, or we are taking block to a distance of 0.2 meter, and then we are leaving it. Means you must have studied in SHM ki if we have, suppose we have a block here, simple pendulum here, and this is in rest. This is in rest. Done. What I'm doing at t equal to 0, I'm just lifting it. I'm taking it up a little up by an angle theta, and I simply took it up and then I released it. Then, so what will happen? If I will release it, it will perform SHM of what amplitude? Of angular amplitude theta. Then, so amplitude gets decided by to what distance we have taken it from its normal position, from its equilibrium position. So initially, unstressed spring means equilibrium में है, कोई force नहीं लग रहा, कोई compression या extension नहीं है, there is no tension in the spring. It means this was the equilibrium position, right? Now what is happening? From equilibrium position, I took block to a distance of how much? 0.2 meter. 0.2 meter. Okay? I took it there, and after taking it here, I released it. So if I release it, what will happen? This block will start moving in this direction. It will go till equilibrium. Again, it will go beyond equilibrium in this direction until it will compress a spring by what distance? 0.2 meter. Because 0.2 meter is now going to be its amplitude. Done. So this is happening. It then executes simple harmonic motion with angular frequency that is given pi by 3. And at t equal to 0, one more thing is happening. One thing was what? At t equal to 0, we stretch the block by a distance of 0.2 meter and then release it. And also at t equal to 0, we are projecting a particle P. Its position from origin is 10 meter at with a velocity of v at an angle 45 degree with a horizontal. Done as shown in the figure. Now point P is at a horizontal distance 10 meter from O, that is given. If the pebble hits the block at t equal to 1 second, at t equal to 1 second, what is happening? This pebble, this stone is able to hit the car. My voice is low. Is it happening with everybody? I'm speaking as usual. मेरी आवाज धीमी आ रही? Anyone else? Yes. कोई और बताओ? Anyone else? Let me know if my voice is really very low. Oh my God. Fine now. Okay. So what we need to calculate at t equal to 1 second, what is happening? At t equal to 1 second, this is hitting the block. Done. So we have to calculate the value B. अब आप देखो what will happen. You just needed to write it carefully. You just needed to draw things carefully. ठीक है? तो चलो यहाँ पे हम देखते हैं कि at t equal to 1 second what will happen. At t equal to 1 second it is hitting now. So when this stone will hit the block, if this stone is hitting the block, it means this stone has come down from air to the ground. जैसे मेरा डायग्राम कुछ ऐसा है, सपोज कर लो एट t इक्वल टू 1, सपोज ये इक्विलिब्रियम पोजीशन है, x इक्वल टू 0 का, यहाँ पे इक्विलिब्रियम के लिए वैसे तो x इक्वल टू 0 इज गिवन हियर, बट इक्विलिब्रियम पोजीशन में दिखा रही हूँ. सपोज दिस इज इक्विलिब्रियम पोजीशन, and from equilibrium position at t equal to 1 second my block is somewhere here, then shifted towards this at t equal to 1 second. And if at t equal to 1 second this stone is hitting the block, how it is possible? This stone is in projectile motion. ठीक है, कुछ ऐसा projectile motion में done. अब यहाँ पे देखो ये ब्लॉक का जो डायमेंशन है, we need to ignore its height, क्योंकि this is a small block now. This is almost a point object. So we need to, like, nothing is given in the question. Nothing is given about its height now. Nothing is given about its height, right? So what we need to do here, we need to ignore its height. We need to assume that its height is almost 0. Done. So if a stone is hitting this block, it means it has completed its projectile motion. It has come back to the ground once again. It means how much time it must have taken to reach here. It must have taken time of flight equal to time. So iska time of flight kitna ho jayega? 1 second. Done. And how much distance it must have covered equal to its range. Okay. So in t equal to 1 second it is hitting. क्लियर है. सो टाइम ऑफ फ्लाइट का वैल्यू इसका हमें पता चल गया. टाइम ऑफ फ्लाइट इज हाउ मच? टाइम ऑफ फ्लाइट इज 1 सेकेंड. नाउ व्हाट विल बी द वैल्यू ऑफ रेंज? रेंज का फॉर्मूला यू ऑल नो ना, दैट इज इक्वल टू हाउ मच? इट इज इक्वल टू ux into uy, 2ux uy by g, if I'm not wrong. This is this. Then so 2 ux का वैल्यू क्या होगा? v cos थीटा. uy क्या होगा? v sin theta. Again cos theta sin theta value will be same, that is 1 by root 2. So what I am going to write here, v square into 1 by root 2 का square, that will become 1 by 2 into g. So 2 will get cancelled and this will be v square by 10. ठीक है. So this is my range. This much distance it has covered. Now if it has covered, range will be this much. Yes, done. So this much distance it has covered, v square by 10. Now what will happen at t equal to 1 second? Where will be my particle? That I need to calculate now. So at t equal to 0, where was my block? My block was at equilibrium position at here, at x equal to 4.9. क्योंकि unstressed length of a spring was how much? 4.9. So at t equal to 0, it was at 4.9. Now we need to see at t equal to 1 second where the block is. So simply first what you will do, you will write the time period value, or you just need to write its equation. How we will write the equation of this SHM? SHM का equation लिखने के लिए कल ही मैंने बताया था, you simply write x equal to a sin omega t plus 5. Done. Clear है? So what is happening here at t equal to 0? What we have done at t equal to 0, we have a stressed spring by 0.2 meter. Done. So at t equal to, for calculating phi, we need to put t equal to 0. Now that I am going to do. So at t equal to 0, x का value क्या है? At t equal to 0, x we simply stress test by this distance now. Sorry, at t equal to 0, x was not 4.9. At t equal to 0, it was further stretched by 0.2 meter. Done. So, are you getting my point? एक second रुक जाओ, मुझे draw कर लेने. What was happening here? चलो मैं block पे focus करती हूँ. So यहाँ पे ये spring था और यहाँ पे ये था, ठीक है. हमारा इन द क्वेश्चन इट इज गिवन कि दिस इज टेकन एज ओरिजिन, लेकिन अगर मैं इक्विलिब्रियम पॉइंट को फॉर अ टाइम बीइंग अगर मैं ओरिजिन लेकर चलूं, इसलिए मैंने यहाँ पे लिखा था इफ आई एम कंसिडरिंग दिस एज x इक्वल टू 0, क्योंकि फॉर राइटिंग द इक्वेशन ऑफ SHM we need to deal with the equilibrium point as origin, right? So I am considering this as an origin. Now at t equal to 0, what happened? We took it beyond it by how much distance? 0.2 meter. 2 meter. So at t equal to 0, x का value is how much? 0.2 meter. Done. I'm going to write the equation of SHM. So x equal to a sine. In general हम लोग SHM का equation ऐसे लिखते हैं. Calculate the value of phi. For that we put t equal to 0. So t equal to 0 if I am going to put, so at t equal to 0, x का value कितना है? 0.2 meter. That is equal to the amplitude only. So x amplitude के बराबर हो जाएगा, है ना? At t equal to 0, sin phi. So phi का value कितना आ गया? Pi by 2. यानी कि मेरा equation of SHM will be what? X equal to a cos omega t. ऐसे भी आपने पढ़ा होगा कि if our block is initially at extreme position, equation of SHM will be a cos omega t. And if my block is initially at equilibrium position, matlab initially means at t equal to 0, then our equation of SHM will be a sin omega t. Done. So here it will be a cos omega t. Now we have to see ki at t equal to 1 second, where will be the, what will be the value of x? तो x इक्वल टू, अब आप लिखो 0.2 था एम्पलीट्यूड कॉस ओमेगा का वैल्यू क्वेश्चन में कितना दिया हुआ है, ओमेगा गिवन इज पाई बाई 3, सो यहाँ पे आप लिखो पाई बाई 3 इंटू 1 सेकेंड, कॉस 60 का वैल्यू क्या होता है 1 by 2, so x is how much 0.1 मीटर, प्लस में दिया है, प्लस में 0.1 मीटर का क्या मतलब है, दिस वन इज द इक्विलिब्रियम पोजीशन प्लस this direction minus this direction. Again, while writing SHM equation, consider equilibrium position as the origin. Relative to that, write everything. So whatever answer you are going to get, x equal to 0.1 meter, this one you are getting from the equilibrium position, not from this one. Okay, that is why I wrote it here separately. तो अब आप देखो x equal to 0.1 meter पॉजिटिव में आया है, यानी कि at t equal to at t equal to 1 second, my block is at where? My block is at 0.1 meter. Done. So from origin now let's see, from origin my block is at what distance? This equilibrium position is from origin at a distance of 4.9. This is extra 0.1 meter ahead. So the total distance, this one is how much? This one is 5. So from this position, this distance is how much? Again 5, क्योंकि total distance was 10. So range का value क्या दिख रहा है यहाँ पे? If block has hit the, if a stone has hit the block at this position, it means range value is how much? 5 meter. So मेरा b square by 10, how much we got? 5. Done. Range I have calculated now. So v square का value क्या हो जाएगा? 50. v क्या हो जाएगा? √50 meter per second. So question was not difficult if you are aware of how to write the SHM equation. Simple था. If you know things, it was like initially you will see at t equal to 0, what is that extreme position? So equation of SHM is x equal to a cos omega t. A value is 0.2 meter. Omega value is given. So calculate the position of block at t equal to 1 second. That is at 0.1 meter from the equilibrium. So here, what is its distance from the stone? Now let's see that. So that is 5 meter. It means if it is hitting it in 1 second, range is 5 meter. So range का formula put करो and simply equate it. That way you will be getting the answer. So the answer is this. ठीक है? Now do this question. Take some 3 minutes again, not more than that you will require actually. Read the question carefully and do it. v की वैल्यू कहाँ आई थी, आ जाती थी, लिखने की जरूरत नहीं पड़ती। रेंज का वैल्यू हमारा कितना आया, रेंज का वैल्यू आया v²/10 वंस, बट रेंज तो नहीं पता ना। रेंज पता करने के लिए जैसे रेंज का वैल्यू हमें आया v के टर्म में आया ना v²/10, v तो हमें निकालना है। सो रेंज का वैल्यू वी मस्ट नो इन सम डिजिट ना, and that value is 5 that we have got from the equation of SHM only। ठीक है, क्योंकि how you will decide कि in 1 second how much distance this block has traveled, you must have an equation of x versus t ना। done। so range का formula, तो range का value हमें आया v के टर्म में v²/10, we need to equate it to some digit ना to get the value of v। that is why I tried calculating range from the equation of SHM, क्योंकि from there only it was possible। एक बार ध्यान से क्वेश्चन को फिर से देखना, ठीक है। एनीथिंग एल्स? कोई डाउट है तो बोलो। Once, is it clear? Okay, this is L actually, this is L greater than L naught। L naught is your initial length, okay? So these are L actually। यहाँ पे ये L है, this is L naught, and this is L again। Formula everyone remember for time period calculation of a spring mass system? सबको याद है? Again, this question came in 2022 G, and this question is damn easy। You just need to remember the formula of time period, it will come under EG section। what is the formula for time period? 2 pi root under m by k, right? चलो 1 more minute I am giving, क्योंकि already I have given you some 4 minutes, no 5 minutes। You should have done this question, yeah? What happened? What the question is, on a frictionless horizontal plane, again above of mass 0.1 kg, horizontal plane it is talking about. So let's say this is the horizontal plane, and on this plane above of mass 0.1 kg is attached to a spring with natural length. Suppose कर लो ऐसा ही कुछ लेते हैं. This bob is attached with a spring. Its natural length is how much? Let's take this is an equilibrium position. So this will be the natural length, and this is equal to 0.1 meter. This is the equilibrium position. Then now what is happening? Given that a spring constant K is changing actually, if L is greater than L naught, if length of a spring is greater than natural length, then a spring constant is this one. And if length of a spring is less than L naught, spring constant is how much? This much. Okay. Initially, the bob is released from L equal to 0.15 meter. Initially means at time t equal to 0, x is not 0. At time t equal to 0, what is happening? We are extending this spring by what distance? We have taken it in this direction. क्योंकि stretch कर रहे हैं ना, if you are stretching it, we won't move the block in this direction ना. So with by how much distance we have taken it up there, that distance is our 0.15 meter. So this is 0.15 meter. Now what will happen? 0.15 meter से हमने इसको इधर लेकर गया, like we took it there. Now what will happen? After that we are releasing it. If we are releasing it, it will start performing SHM. And that SHM will have some time period. We need to calculate that time. Again, यहाँ पे confusion ये है कि what value of K we will be taking. So that we will be taking according to the length of the spring. Now you just see at t equal to 0, my spring is stretched by 0.15 meter. It means its length is 0.1 plus 0.15. So definitely here its length is what? Greater than L naught. As it will go in this direction, till it will reach at the x equal to 0, its length will be greater than L naught. So for this distance, we will calculate its time period by this formula. Then we will put the value of K as what? We will be putting the value of K as 0.009. Done. 0.05 from the mean position. Is it like that? अच्छा, L equal to 0.15 लिखा है. L naught is this. Okay, L is 0.15 meter. Okay, done. Thank you. So, stretching length जो बोला है ना, when we are stretching it, its total length of a spring is 0.15 meter. It means this distance will be only 0.05 meter. ठीक है? That will be 0.05 meter. Thank you. Clear? So this much distance. Now we have to deal with the time now. So let's deal with the time first. So while calculating time it takes to travel from this point to this point for the first time, I will be taking value of K as 0.009. Now what will happen? At this point, it will come and then it will start moving towards this direction. So now compression will happen. So definitely in this timing, what will happen? L will be less than L naught. So if L is less than L naught, what we will be considering? K2 0.016. Now this spring will go up to maximum compression of 0.05 meter. And after maximum compression, it will again come back to the equilibrium position. So if it is coming back to the equilibrium position, during that timing also, L is less than L naught. So if this block goes to maximum compression and then come back to the equilibrium position, during this whole timing, what is happening? K value will be taken as 0.016 because L is less than L naught. Again, what will happen? क्योंकि हमें time period निकालना है, so again it will move on to this direction. क्योंकि time period का मतलब जहाँ से start हुआ था वहाँ पहुँचना. So it started from this position, so we will bring back to this position and then we will say कि one time period has happened. Done. So again, if it will come back to this position, during that timing, L will be what? Greater than L naught. So for half of the time period, L is less than L naught, and for half of the time period L is greater than L naught. So total timing आप कैसे निकालोगे? टाइम पीरियड क्या हो जाएगा? T1 plus T2, and T1 will be like half of the time period के लिए k का वैल्यू क्या ले रहे हो? 0.009. So half of the time period means pi root under m by k. k का वैल्यू मैं क्या लूं? एक केस में 0.009 लूंगी और सेकेंड केस में मैं क्या लूंगी? दैट विल बी मास इज हाउ मच? 0.1 ना, तो यहाँ पे 0.1 ही लिख लो आप. 0.1 by how much? 0.016. So how much value we are going to get? 10 to the power minus 1, 10 to the power minus 3, 10 to the power 2 ऊपर जाएगा, यहाँ पे भी 10 to the power 2 ऊपर जाएगा, so 10 बाहर आए. Now 10 into pi will be equal to how much? 1 by 3 plus 1 by 4. So अब आप इसको solve कर लो. So how much value we are going to get? This will become 7 by 12. 7 by 12 into 10. If I have done it correctly, 1 by 3 plus 1 by 4. So yes, 7 by 12. And time period is given as n pi. So n का value क्या होगा? That's the question. So 70 by 12 into pi. So this will be close to nearest integer, then the integer closest to n. n का वैल्यू अगर यहाँ से आप निकालो तो कितना आएगा? 5.100. So it will be greater than 5 now. 8 something आएगा. Done. So if you are going to round it off, you will be getting what? 6. So the answer will be what? 6. Clear है? So यहाँ पे कुछ भी नहीं करना था. For half of the time you needed to take k equal to 0.009, and for half of the time you needed to take k equal to 0.016. So whole time period का formula होता है 2 pi m by k. Half of the time you are taking k as that, तो half के लिए 2 pi नहीं लिखोगे, pi into m by k लिखोगे. ठीक है? So that was the thing. Now everyone do this question. Again, yesterday I have discussed how you will decide which one is in series, which one is in parallel. So done that, you know. But here what concept will come in use? In series what happens? Which tension remains same or displacement remains same? That will come into use here. So or in short, you just need to look at the question carefully. Just looking up will help. Do this now. I'm giving you some 3.5 minutes. Okay, enough time I'm giving. Just do it. How you people are solving? Let me know anything. Amplitude of point P we have to calculate. Means we have to see by what maximum distance point P can move to this direction or to this direction. Then, so that will get guided by maximum distance or maximum extension or compression by which spring? Just tell me that first. You have to calculate the amplitude of point P, right? So we have to see by what maximum distance this point P can move to this direction or to this direction. Then, so this will get guided by which one? Yes, once. Then now question is solved now. If that is known, जैसे यहाँ पे just imagine this is a spring now. So if M mass is moving in this direction, first K2 will move. There will be some extension in K2 first. So this is moving. At that point, P won't move, but P will definitely move if K1 has got extended by certain distance. Done. So if K1 is getting extended by delta L, P will get extended by delta L, right? So amplitude of P will get guided by K1 spring. Now you need to see what maximum displacement K1 spring can have if maximum displacement by mass M is A. That is given in the question now. Amplitude of this SHM is how much? A. It means this mass M can move maximum up to how much distance? A. And that A will get divided between K1 and K2, right? Suppose K1 is getting extended by X1, K2 by X2, such that X1 plus X2 will be what? A. Clear hai? Now let me know the answer. चलो आप लोग जल्दी से बताओ क्या हो. These two springs are in series or parallel? Are they in series or parallel? End to end connected hai. They are in series, right? And in series, what things remain constant throughout? Displacement is not remaining constant now. Yes. What will remain constant throughout? Just yesterday, that is why I discussed those things in a very short amount of time though. But I discussed now if a springs are in parallel, displacement by block M will be same as displacement by both the spring. So here displacements are going to be same, but tension can be different depending on their spring constant if displacement is same. In series, what happens? अगर आप सीरीज में दो स्प्रिंग को रखे हो, so we can see it like there is a long string, and this long string, if it is massless, क्योंकि even if not given, spring is massless. It's generally taken as massless. And you know that if a spring or anything, a string is massless, tension throughout remains the same. So here tension will remain same because they are forming a single string, massless single string. So tension will remain the same. So if K1 spring is getting displacement X1 and K2 getting displacement X2, tension in this spring will be how much? K1 spring, K1 X1. Tension in this portion of a string or a spring will be how much? K2 X2. Since they are a part of a massless long string, then from here to here they are massless now. So if system is massless, tension throughout will remain the same. So just equate it. These two are equal, right? Now what else? X1 plus X2 will be equal to A. Solve these two. You just need to find out X1 because amplitude of P will be same as X1. So we need to calculate X1. So एक काम करते हैं, let's put the value of X2 here. So X1 plus X2 can be written as what? K1 X1 by K2. That is equal to A. Now you see carefully here, X1 को common ले लो आप. This will become K1 plus K2 divided by K2A. So X1 is equal to how much? K2A divided by K1 plus K2. So the correct answer will be what? B. Okay. Now, if you have any doubt in SHM, मुझे एक बार बता दो in what things you are getting problem. I will solve that for a while. Let me know. जैसे what should things should be clear in your head about SHM, how to write the equation of SHM. First thing. Second thing, if you have written the equation of SHM, from there you can calculate velocity, acceleration. Done. How to calculate the time period. Third thing. And how to identify springs are in series or parallel. Again, identification is not enough. What is the meaning of a springs being in parallel? Displacement same. A springs being in series, tension same. So these things we need to know. अगर किसी को कोई डाउट है इस चीजों में तो let me know. If not, then you need to solve some more questions. Just sit with some question, 2 or 3, and try to do it with yourself. Then you will get the thing. ठीक है? Kx equal क्यों कर दिया? आपने मैकेनिक्स में पढ़ा होगा ना. मैकेनिक्स में हमने क्या पढ़ा है? हमने ये पढ़ा है, जैसे आई एम जस्ट गिविंग यू वन एग्जांपल. जैसे आपने पढ़ा होगा कि, या फिर हम लोग बहुत सारे क्वेश्चंस को डील किया है, और अगर आपको याद हो, इफ यू पीपल रिमेम्बर इट, जैसे अगर सपोज कर लो हमारे पास ये ऐसा कोई एक सरफेस है. एक सेकेंड, जस्ट गिव मी सम टाइम ना. सपोज कर लो एक ऐसा सरफेस है, मेरे पास 3-4 ब्लॉक है. ठीक है, मैंने कुछ ऐसे ऐसे कर दिया, ऐसे ऐसे कर दिया, ऐसे कर दिया. ठीक है, अब मैंने क्या कहा कि ये मेरा 1 kg है, ये 2 kg है, ये 3 है, ये 4 है, या फिर सारे का मास इक्वल भी है, डजंट मैटर. नाउ हाउ मेनी स्ट्रिंग यू आर हैविंग हियर? स्ट्रिंग कितने हैं यहाँ पे? स्ट्रिंग मेरे पास कितने हैं यहाँ पे? एक ये है, एक ये है, एक ये है. Now question is, will tension remain same in all spring? How we will decide that? So you just need to see कि दो स्प्रिंग के बीच में कोई मास जैसी चीज तो नहीं आई है. So if I say one spring and two string, sorry string I am talking. So a string is same as a spring, क्योंकि स्प्रिंग में भी एक्सटेंशन होता है और टेंशन आता है. स्ट्रिंग में भी अगर स्ट्रिंग एक्सटेंड होगा तभी उसमें टेंशन आता है. So these are also kind of those kind of strings, right? So not similarly but tension के हिसाब से सेम है. अब आप देखो what will happen, 1 and 2 के बीच में एक मास है 2 kg का. So definitely इस स्प्रिंग में जो टेंशन, इस स्ट्रिंग में जो टेंशन होगा, अगर T1 है तो यहाँ पे T2 हो, डिफरेंट होगा, क्योंकि इन दोनों स्प्रिंग के बीच में एक मास आया है. ठीक है, अगेन T2 और इस स्प्रिंग में, इस स्ट्रिंग में टेंशन अगेन डिफरेंट होगा, नॉट सेम, बिकॉज इन दोनों के बीच में एक मास आया. Why it is happening now? The question is this. तो ये इसलिए हो रहा है क्योंकि अगर आप एक सिंपल सा एग्जांपल ले लो, सपोज कर लो कि मैंने एक मास कंटेनिंग स्ट्रिंग ले लिया, एक ऐसा स्ट्रिंग लिया है जिसमें क्या है, मास है. अगेन इस स्ट्रिंग का मास सपोज कर लो मैंने स्मॉल m लिया और यहाँ पे एक कैपिटल M मास ले लिया. नाउ व्हाट विल बी द टेंशन एट डिफरेंट पॉइंट्स ऑफ अ स्ट्रिंग? नाउ लेट्स चेक विद दैट. तो आप कैसे चेक करोगे? सपोज कर लो मुझे यहाँ पे टेंशन चेक करना है. अगेन अगर मैं इसका एक सिंपल सा डायग्राम बनाऊं, यहाँ पे एक मासलेस स्ट्रिंग ले लूं और यहाँ पे एक मास m ले लूं, तो इस स्ट्रिंग में टेंशन क्यों आएगा? अगर आप इस मास m को कनेक्ट नहीं करोगे देन दिस स्ट्रिंग विल हैव नो टेंशन. लेकिन अगर जैसे ही मैंने मास को कनेक्ट किया, वो मास स्ट्रिंग को नीचे खींचेगा बिकॉज ऑफ इट्स ग्रेविटेशनल फोर्स. डन. सो देन दिस स्ट्रिंग विल स्टार्ट गेटिंग टेंशन. डन. हियर व्हाट विल हैपन, इस पॉइंट को अगर मैं देखूं तो इस पॉइंट को खींचने के लिए हाउ मच मास इज प्रेजेंट? ऑब्वियसली दिस कैपिटल M मास इज देयर, बट मास contained in this length of a spring will also extend this point P, will also apply force on this point P. Again ये वाला मास नहीं करेगा, है ना? Then जैसे जैसे we will go up, more and more mass points will have in downward sense. So more and more gravitational force it will feel, and more it will get tension. Done. So if mass is there, definitely tension is going to change. But if mass is not there, if it is massless, tension throughout will remain the same as here in this or a string. Done. So similarly here, यहाँ पे springs are massless, so throughout tension will be same. tension in this spring I'm saying K1x1. In this spring I'm saying K2x2. So these two must be equal because this whole length is massless. So tension I equated equal. That's the logic. Now x1 plus x2a. I hope I answered. Yes. Once anyone else? Okay. चलो ठीक है. I'm trying my best to make you people understand something, but अगर नहीं हो पा रहा तो चलो ठीक है, कोई नहीं. We need to give effort, है ना? This question also came in 2022 or 21, I remember. So this is again recent, very recent question. This question we need to solve very wisely. If you are not doing wisely, we are going to get lots of English. तो कल को करते हैं इस क्वेश्चन को. उससे पहले हम लोग कुछ देखते हैं. And that देखना is in wave. So I'm going to discuss wave. Wave में हमें क्या पढ़ना है? We just need to know how to write the equation of wave. First thing, दो तरह के wave होंगे. Traveling wave, stationary wave. I will discuss how they will be different, and then I will discuss velocities of traveling wave in different medias, and finally SHM from wave. They're quite easy if you really know the concept. Okay, so they are not at all difficult. Am I audible, everyone? Okay. Chalo, ठीक है. So what I have taken here, equation of a progressive wave. What we mean by progressive wave? Suppose कर लो यहाँ पे जैसे if you have to generate a wave, we use a source, right? So wave is what? Nothing but energy. So हमारे पास एक energy का source होगा, and that source will generate energy, यानी कि wave. Done. So if our energy has this shape, so what will happen? This source is generating this energy, this wave, and this wave will get on traveling ahead like this. So it will move. Jैसे the moment you drop stone in water, what happens? That ripple effect starts from the center and it travels outward. Similarly here, this is acting as a pebble, and in this media it is generating wave like this. So wave ka shape मैंने sinusoidal लिया. Done. So this is this. Now what will happen because of this wave getting traveled in a media? Suppose कर लो this media is a solid media. So this media will have atoms everywhere. Done. So what you basically need to understand is कि what happens when this wave gets on into media. क्या होगा? आप यहाँ पे देख लो. मैं कुछ 2 points लेने वाली हूँ. ठीक है? Suppose I have taken this point and this point. So what will happen? At t equal to 0, wave got generated. So अगर आप wave का t equal to 0 पे snapshot ले रहे हो, photo ले रहे हो, then that snapshot will look like this, the one that is visible in your diagram, right? So this is the snapshot of wave. Now, how we are getting that snapshot visible? वो ये रहा है कि जो मीडिया का जो पार्टिकल्स था ना, यहाँ पे कुछ पार्टिकल्स है, यहाँ कुछ पार्टिकल्स है, सो यहाँ पे कुछ पार्टिकल है. दिस पार्टिकल गॉट अप बाय दिस डिस्टेंस, this particle got up by this distance, this particle by this particle by this. So definitely this snapshot is getting created by particles of the media. So particles of the media, because of energy it received, it has jumped to this position. Okay? At t equal to 0. So at t equal to 0, this snapshot we are getting because particles of the media have jumped to different distances according to energy it has received. That's the basic point. Now what will happen when wave will move forward? That is what we need to understand. जैसे मैंने यहाँ पे देखो, ध्यान से देखो, t equal to 0 पे snapshot ऐसा हुआ. Definitely this is a traveling wave. It will travel forward. Done. अब ये forward travel कर रहा है, तो पहले ये वाली energy ये point receive किया था. ठीक है? So this point jump to this point. Now what will happen to this point? Which energy has traveled? This वाला energy यानी कि 0. so it will remain at this position. Again, if this wala energy will reach here, this point will come here. If this wala energy will reach here, this point will further come up. If this energy will come here, again it will go down like this. Okay, so what will happen as to this point, अगर मैं इस point को focus कर लूं P पे, तो इस P point पे all form of energy will reach here of this snapshot. ठीक है, so this point will go up like this also, go down like this also, and in between it will cover all the distances. So it seems like ये point जो है, ये point, this will perform SHM. It will go up to maximum level, it will go to certain minimum level, and in between it will keep on traveling. So because of wave traveling in the media, particles of the media are performing SHM. Simple. ठीक है, अब इसमें हमें ज्यादा नहीं पढ़ना है, we just need to understand it. ठीक है, so these particles will perform SHM, done, and each particles will perform SHM ना, यहाँ का particle भी करेगा, यहाँ का भी करेगा, और सबका ही amplitude क्या होने वाला है, same, क्योंकि at each point highest energy will reach, at each point lowest energy will reach, done. So what will happen? Particle of the media will perform SHM of equal amplitudes. This is what you need to remember. ठीक है, तो चलो इक्वेशन कैसे लिखेंगे? अब इक्वेशन पे आते हैं, हमें ज्यादा दिमाग नहीं लगाना, we just need to come to the equation. So equation हम कैसे लिखेंगे? Y is what? When wave was traveling, our particles were getting displaced in the y direction, है ना? And wave was traveling in which direction? X. Wave was traveling in x direction. Particles were getting displaced in the y direction. So equation of wave overall I'm going to write as y equal to function of x minus vt. Again ये कैसे आया? We won't go to that क्योंकि वो अभी हमें help नहीं करेगा. But yes, knowing it will also help you in solving the question. So y will be written as function of x minus vt. Don't get confused with this equation. Don't think like कि ये काफी ज्यादा बेकार लग रहा है क्योंकि रीजन नहीं समझ में आ रहा है ये कैसे हुआ. Don't try to understand that, but try to consume कि equation of wave, traveling wave will look like function of x minus vt. You all are maths student. You understand the meaning of this function. This function can be sine function. So अब मैं लिखने जा रही हूँ sine function के फॉर्म में equation. So y is equal to amplitude sine kx minus omega t. This is. Again, you must be thinking why I wrote this. Why it is important? Because in the question, this function won't always be your sine function. If in question, the wave is given as some other function that I will discuss through questions, ठीक है? तो वहां पे भी तुम्हें ज्यादा तीर मारने की जरूरत नहीं है. Just need to remember कि ये function function के अंदर variable क्या होता है, x minus b. ठीक है? जैसे देखो यहाँ पे how it will come useful. जैसे इस equation को मैंने यहाँ पे function sin use किया, and if I'm asking what is the velocity of wave here, how you will answer? You just need to remember कि wave equation is written as function of something और variable क्या है, x minus vt. So यहाँ पे variable क्या है, kx minus omega t. We need to write it in this form. ठीक है? How we can do that? A sin k को कॉमन ले लो क्योंकि यहाँ पे x के साथ कोई कांस्टेंट नहीं है, तो आप k को कॉमन ले लो. k को मैंने कॉमन लिया, x माइनस ओमेगा बाई के टी. सो अब आप ध्यान से इसको देखो तो अंदर जो ये दिख रहा है इट इज समथिंग काइंड ऑफ x माइनस वी टी. सो वेलोसिटी का वैल्यू क्या हो जाएगा, ओमेगा बाई के. ठीक है, वेलोसिटी का वैल्यू क्या होगा, ओमेगा बाई के. सो दिस इज द velocity of a progressive wave in terms of its angular frequency and wave number. This is angular frequency ना, this is wave number 2 pi by lambda. ठीक है, wavelength का मतलब सबको पता है. You all know what's the meaning of amplitude and all. Done. चलो. Now speed of transverse wave. आपने दो तरह का wave पढ़ा होगा also in your 10th class. Like there used to be two kind of wave, transverse wave and longitudinal wave. Transverse wave में क्या होता है? The one we discussed recently was transverse wave. If energy is flowing through medium, particle medium will get displaced in direction perpendicular to the direction of motion of wave. So in our case, wave was traveling in forward direction and particles were getting displaced in vertical direction. So this is a transverse wave. Longitudinal wave में क्या होता है कि energy is getting traveled in this direction. Also particles are getting displaced in this direction. ठीक है? So both directions are same. That is longitude. Again, हमें जो पढ़ना है, let's focus on that. Speed of transverse wave on string. अगर एक string पे, अगर suppose करो question is given कि string is fixed and on it wave is traveling like this. What will be the speed of wave? So you will calculate tension of a string. You will a string, and you will see ki what is the mass per unit length of a string. So a velocity of wave will be root under T by mu, where T is tension and mu is mass per unit length of the string. ठीक है? अब आप देखो speed of longitudinal wave, basically sound wave we are talking about. So if sound is traveling in fluid, air or water, how we write its velocity? We write its velocity like bulk modulus of the media divided by density of the media. ठीक है? So bulk modulus by density. Done. But यानी कि टॉप पे हम लोग क्या लिखते हैं? Elasticity of media. And if media is fluid, elasticity will be bulk modulus. If media is solid, elasticity will be Young's modulus. So if your longitudinal wave is traveling in on a string or in some solid media, we will write it as gamma by rho, where gamma is Young's modulus, rho is again density of the media. And if it is traveling in fluid, we will write beta by, that is beta is bulk modulus and rho is your density of that fluid. ठीक है? चलो, अब एक छोटी सी चीजें जो दी हुई है in your textbook also, है ना? So for ideal gas media, if I'm saying कि my sound is traveling in an ideal gas, so earlier scientists used to think na कि if sound is traveling in ideal gas, then process that is happening is isothermal, means sound is traveling isothermally. It's not causing any change in the temperature of media. ठीक है? So if isothermal thing is taken care of, आप बीटा का वैल्यू क्या लिखते हो? बीटा का वैल्यू लिखते हो ना P by delta V by V. Done. And if you are going to put, if you are going to calculate it by using ideal gas equation, PV equal to क्या लिखते हो? nRT. And if you are going to put temperature constant, क्योंकि they considered कि when sound travel through media, temperature remain constant of the media. So if you are going to change, take that पार्शियल डिफरेंशिएशन अगर करोगे तो एक बार प्रेशर को कांस्टेंट रख के करोगे, ऑल दिस थिंग्स यू नो. सो एनआर डेल्टा टी ये 0 हो जाएगा. सो फ्रॉम हियर यू कैन गेट द वैल्यू ऑफ व्हाट, गेट द वैल्यू ऑफ बीटा, राइट? सो इफ यू आर गोइंग टू कैलकुलेट दैट, you will get value of this equal to what? It will come as beta by rho will come as pressure by rho. ठीक है? It will come as something like this. Done. क्योंकि यहाँ पे जो P है ना वो change in pressure. Then this delta P is that. तो मैं यहाँ delta लिख देती हूँ वैसे. Done. So you will get the value. Now rather later what happened? Laplace was a scientist and he corrected. इन्होंने कहा कि नहीं, when sound travels in a media, the process is actually adiabatic, done, not isothermal. And in that case, जो हमने अभी calculation किया ना, PV equal to nRT we used. If process is adiabatic, we will be using which formula? PV gamma equal to constant. And if we are going to partially differentiate it, again you will get the value of bulk modulus, and that will come as gamma into pressure. ठीक है? So Laplace correction के according gamma P by rho. Question में लिखा होगा consider Laplace correction. Then velocity you will be writing as gamma P by rho. Done. चलो. So how we add two waves, that also I have discussed in your wave optics. जैसे suppose two waves are given, A1 sin kx minus omega t, A2 sin kx minus omega t plus 5. Again I have taken their wave number to be same, their angular frequency to be same. Done. So what is the phase of wave? Phase होता है जो भी साइन के अंदर एंगल है, that is called phase. Phase constant क्या होता है? Whatever is independent of time. ठीक है? So this thing we have discussed. अगर मुझे इन दोनों वेव को ऐड करना है and we have to say कि what will be the amplitude of that added wave, we can do it vectorially. I have said before also. So how vectorially? We will consider y1 as a vector, y2 as a vector. ठीक है? So if you are going to consider y1 as a vector, सपोज कर लो kx माइनस ओमेगा टी को मैं थीटा इक्वल टू 0 वाला लाइन मान रही हूँ. ठीक है. So my first vector y1 vector will lie along this line, done, and its length will be equal to a1. I have said earlier also. So if I'm going to draw the second line, second vector with reference to this, where will it lie? क्योंकि kx minus omega t I'm considering as theta equal to 0, so it is plus phi of that. So it will move plus phi of that. So a2, done. What you have to do, simply calculate the phase difference. Phase difference यहाँ पे phi आएगा. दो वेक्टर ले लो a1 and a2. Angle between these two is phi. Done. Now a net will be equal to how much? A net will be equal to a1 square plus a2 square plus 2a1 a2 cos phi. जैसे आप वेक्टर को ऐड करते हो, nothing else. ठीक है. So that way we can do. I have just taken here a1 a2 we have written like this. And if you are going to calculate the net, y1 plus y2 line will look like this. This line I have taken as theta equal to 0 wala line. Done. So if you have to write the y1 plus y2 in this form of equations, then we can write it like a dash sine kx minus omega t plus theta. क्योंकि जो y1 plus y2 है वो theta equal to 0 line से somewhat upward है. कितना angle upward है? That we need to calculate. If this is theta, then a dash we have already calculated. I calculated just now. Its value will be how much? a1 square plus a2 square plus 2a1 a2 cos phi. Theta we can calculate ना. यहाँ पे आप perpendicular draw कर दो. So sin theta will be equal to a1 by a dash, है ना? So sin theta also you can calculate. So theta यहाँ रख सकते हो. Overall you can write the equation again for y1 and y2. ठीक है. अब देखो यहाँ पे रिफ्लेक्शन ऑफ वेव इज अ वेरी इंपॉर्टेंट थिंग टू डिस्कस, क्योंकि इन वेव ऑप्टिक्स आल्सो आई हैव सेड कि इफ वेव इज गेटिंग रिफ्लेक्टेड बाय डेंसर मीडिया देयर विल बी एन एडिशनल फेज चेंज ऑफ पाई. तो यहाँ पे मैंने एक एग्जांपल लिया है, एक स्ट्रिंग लिया. दिस इज फर्स्ट स्ट्रिंग एंड दिस इज योर सेकंड स्ट्रिंग. द वन दैट आई हैव मेड थिकर हैज हायर डेंसिटी. ठीक है. सो इसका डेंसिटी आप ρ1 मान लो, इसका डेंसिटी आप ρ2 मान लो. सो व्हाट आई हैव टेकन हियर, आई हैव टेकन ρ2 is greater than ρ1. So if wave is traveling from one string to another, so at this point what will happen, it will try to go from rarer to denser media. Now what will happen, I have said if wave is falling on rarer to denser media and if it is getting reflected, that reflected wave will suffer phase change of phi. लेकिन यहाँ पे wave के साथ दो चीज हो सकता है. Either wave can get transmitted, तो transmit हो जाएगा कुछ wave इस मीडिया में, and some wave will get reflected back. Again वो reflect कैसे होगा? With phase change of phi. ठीक है. तो देखो यहाँ मैंने दिखाया, मेरे डायग्राम सेम ही दिख रहे हैं, यहाँ पे एम्पलीट्यूड अलग अलग दिख रहा है बट सेम. ठीक है. तो रेयर से डेंसर मीडिया में जब लाइट जाता है या वेव जाएगा, what will happen? Its velocity will decrease, क्योंकि लेस ट्रैफिक से मोर ट्रैफिक वाले रीजन में चला गया है ना. So its velocity will decrease. Done. Again frequency of wave depends on what? Frequency of wave depends on कि ये किस source से generate हो रहा है. So frequency of wave is not going to change because of change in media. Done. So v by lambda, that is will remain constant. v by lambda किसके बराबर होगा? v by lambda will be equal to frequency. So frequency is constant. Now v is decreasing, so lambda should also decrease. Done. So ये चीजें हैं. Now what will happen to the amplitude? Amplitude is going to decrease. Why? क्योंकि यहाँ पे देखो, this is the source, so it is sending wave, means it is sending energy. So whatever energy it has sent to the rarer media, same energy it is sending to the denser media also. So energy coming is same. So if energy coming is same, it means what should happen? यहाँ पे इसकी velocity तो धीमी हो गई है ना, velocity has decreased, right? So if velocity has decreased, and we have to keep the power same, power of the wave we have to keep the same. What we can do, you know that intensity of wave is directly proportional to amplitude ka square. Done. So what will happen here, its amplitude should what? Actually it needs another level of discussion, but what I will suggest na yahan pe, you just remember one thing, if wave is traveling from rarer to denser media, what is happening? Its amplitude will decrease. And why it will decrease? Why I can answer here, because we have to keep the power of that wave same throughout. ठीक है, so to keep the power same we have to here decrease the amplitude. So rarer से denser में जाएगा, amplitude decrease होगा. If it is going from denser to rarer, amplitude increase. Remember for one thing, second thing automatic हो जाएगा. ठीक है, चलो, क्योंकि we don't need to waste more time. अब यहाँ पे देखो रिफ्लेक्शन ऑफ वेव मैंने दिखाया. फेज चेंज ऑफ पाई का क्या मतलब है? जैसे आप देखो, अगर एक वेव कुछ ऐसे हिट किया यहाँ पे, अगर यहाँ से ये वेव रिफ्लेक्ट हो रहा है, क्योंकि ये रिजिड मीडिया है, वेव एयर में था, ठीक है, दिस वाज ऑन इन एयर सपोज, and suddenly it is encountering a wall, solid wall, so it is falling on a rigid denser thing. So what will happen if it is getting reflected? Phase change of pi will happen. Phase change of pi का मतलब क्या होगा? अगर इसका पाई का फेज, जैसे साइन कर्व आप लोग पढ़ते होंगे, दिस इज साइन कर्व, एंड व्हाट इज जैसे साइन थीटा का कर्व आपने पढ़ा, डन, ऐसा है. पाई का फेज चेंज मतलब इसमें पाई ऐड होगा. तो अगर आप यहाँ पे लिखो पाई प्लस थीटा, सो व्हाट यू विल राइट हियर, माइनस साइन थीटा, डन, माइनस साइन थीटा. माइनस साइन थीटा का ग्राफ कैसा? फेज चेंज ऑफ पाई मींस माइनस साइन थीटा इट हैज बिकम माइनस साइन थीटा, y इक्वल टू माइनस साइन थीटा. How you will draw the graph? You will take its image in the x-axis, क्योंकि y has become negative. तो मिरर इमेज किस में लेंगे? x-axis में लेंगे. So just give me 1 minute. चलो डन है. So यहाँ पे image you are going to take in the x-axis. So minus sin theta का जो मेरा ग्राफ आएगा, that will look like something like this. ठीक है. So phase change of pi means it has just got inverted. तो यहाँ पे भी ये invert हो जाएगा, कुछ ऐसे जाएगा. ठीक है. So phase change of pi has this meaning. But if wave is falling from denser to rarer media, no phase change will happen. And in that case, what will happen? Suppose कर लो कि यहाँ पे एक denser media था और यहाँ से एक wave ऐसे चला, rarer पे fall किया. If it is getting reflected, then initially wave was traveling in this direction. Because of reflection, it will travel in this direction. So it won't change the phase. It will simply go on like this. Without changing the phase, only it will change the direction. Here wave was, incident wave was this. Reflected wave is this. It has changed its direction definitely. Also is phased by an angle of 180 degree. Okay? So that's the image. अब यहाँ पे देखो स्टैंडिंग वेव हमने पढ़ा है. स्टैंडिंग वेव का मतलब क्या है? The way I have discussed traveling wave, similarly I will discuss here this. First thing, how standing wave is formed. Standing wave is formed when wave like first wave हमने लिया a sin kx minus omega t and second wave is a sin kx plus omega t. Means if two wave, जैसे यहाँ पे I didn't discuss की, if here kx minus omega t है, it means ये wave कौन से direction में जा रहा है? If your wave equation looks like a sin kx minus omega t, so it is traveling in plus x direction. If your wave equation is kx plus omega t, it is traveling in minus x direction. So if a wave traveling in x direction and minus x direction gets superimposed, then we get what? Standing wave. तो मैंने यहाँ पे दो वेव लिया है, एक प्लस एक्स में जा रहा है, एक माइनस एक्स में जा रहा है. दोनों का ही वेव नंबर सेम लिया है मैंने, फ्रीक्वेंसी भी सेम लिया है, एम्पलीट्यूड भी सेम लिया है फॉर द सिंप्लीफिकेशन ऑफ कैलकुलेशन. एंड दैट थिंग ओनली वी हैव टू स्टडी. ठीक है. तो यहाँ पे देखो हम क्या करने वाले हैं, y1 plus y2. You all know the maths, sin a plus sin b करोगे. ठीक है. So you will be getting something like this. Now how to interpret this equation? अब आप यहाँ पे ध्यान से अगर देखो तो यहाँ पे जो ये वाला टर्म है ना 2a sin kx, that is the amplitude of y1 plus y2. ठीक है. Amplitude of y1 plus y2 is how much? 2a sin kx, and this is the and this is cos omega t. So amplitude into cos omega t. So angular frequency of that standing wave is how much? Still omega. ठीक है. Now let's read this equation more carefully. जैसे मैंने बोला, this is your amplitude. ठीक है. Amplitude is how much? 2a sin kx. So this amplitude will be different for different value of x. यहाँ पे मैंने एक डायग्राम बनाया. Just see the diagram now. अगर मैं इसको x equal to 0 बुलाऊं, let me call this x equal to 0. So at x equal to 0, you are getting a point which has no displacement. y direction में it has no displacement. Here y is also 0. Done. Now let's see this point. This point is at certain distance x. Okay. So amplitude of this point of the media will be how much? 2a sine kx. Value of x you will be putting. So its amplitude is something like this. Amplitude of this, this point will be how much? This much. Amplitude of this point is how much? This much. Maximum. And amplitude of this point is how much? This much. Done. So amplitude of different points is different in case of a standing wave. Like in traveling wave, I discussed just a while ago, every point of the media will have same displacement, same maximum displacement. That is, their amplitude was same. But यहाँ पे different points will have different amplitudes. Now, इसका क्या मतलब हुआ? So that we will now understand in a more extended way. जैसे यहाँ पे देखो, there are certain points which are having amplitude as 0. यहाँ पे ये point ले लो, इसका amplitude क्या है? 0 है. And this point is called what? This is called node. ठीक है? And here this point, if you take, this has maximum amplitude. This point is called what? Antinode. ठीक है? So this is node, and this point is what? This is antinode. So these are this. Why this is happening? This is happening because why in traveling wave every point was having equal amplitude. क्यों था वहां पे ऐसा? क्योंकि my energy was traveling. ठीक है? वो travel कर रहा था. So if wave is traveling at this point, all energy will cross it. So it will have displacement until maximum displacement is gaining. Okay, so every point will have same displacement, same amplitude, because every point is receiving all snaps of the energy, right? But यहाँ पे इसका नाम ही है standing wave. यहाँ पे क्या हो रहा है ना कि energy is not able to travel. Energy is confined. It is not traveling. It is confined. It is cased in that space. ठीक है? So यहाँ की energy ऐसी है कि this particle can oscillate in this up to this distance. यहाँ पे एनर्जी कुछ है ही नहीं, इसलिए this particle is at rest. ठीक है? यहाँ पे एनर्जी इतनी है कि it can oscillate like this up to this amplitude. ठीक है? So in a standing wave, energy doesn't travel. It remain confined. It remain cased in a space. Different point will have different amplitudes, and some point is called node of zero displacement, antinode of maximum displacement. ठीक है? Equation will look like this, and based on these equations we will be learning standing wave on a string जब बनता है तो कैसे बनेगा, उसका like natural frequencies क्या होंगे. So that I will discuss in your next class. For some 5 to 10 minutes का discussion बचा हुआ है, and after that we will be entirely doing questions on wave. ठीक है? And on Friday, tomorrow is Friday now, I will be discussing wave, and on Saturday I will be taking up AC. ठीक है? Alternating current. Again, that is an easy topic, so that we will be picking up. Done? Anyone having any doubt? बहुत शांत बैठे हो सब. Let me know if anyone is having any doubt. No? Okay, no doubt. Done. ठीक है? तो तुम लोग सही से रहो. Take care of yourself and read properly. Don't take tension. Stay safe. Stay good.